what's the optimal nutrition for stem cells, do you think?
So right now, what a lot of companies are doing in academic centers is platelet lysate. It
Mm-hmm.
also comes from human blood and
Mm-hmm.
specifically the platelets. It's packed with nutrients and growth factors, just like the fetal bovine serum. And it's
Mm-hmm.
considered a good alternative to fetal bovine serum. I mean, it's human based. You don't
Yeah.
have to worry about, any type of xeno issues. The only catch is it's more expensive and it requires extra steps to prepare.
Yeah.
But it is actually seen as more ethical choice, and it's safer, but it does come with the extra cost.
Hey there, welcome to the Recharge Biomedical Podcast. I'm Dr. Edward Park, and if you're curious about regenerative medicine, you've come to the right place. We're diving into the latest breakthroughs in telomerase activation, stem cell exosomes, and all the cutting edge science that's shaping the future of healing and longevity. Let's get started.
All right. Welcome to another episode of Recharge Biomedical Podcast, and I'm your host, Dr. Edward Park. Today, we're very lucky to be joined by Darcy DeFede. And did I pronounce that wrong?
Yes.
Pretty close. Okay. Well, Darcy is a wonderful, experienced person, and we'll get into that. We met when we were both lecturing in Cancun, Mexico about 2 months ago. It was a great time, and she gave two brilliant lectures about stem cell, her experience building stem cell labs for people who went on to be successful or not successful. But a lot of folks in the space, they don't know what they don't know, right? That's the Yogi Berraism. So in life, you have your beliefs, and then you have your experience, and then you have your wisdom. And wisdom comes, unfortunately, with making mistakes. So Darcy will come in and be the cleanup crew, and she'll tell you, oh, this is where you screwed up on the line. But better to hire her from the beginning, because she does consulting, as she did to build a facility in Morocco, so that you can set up the protocols, get the right equipment, train the staff appropriately. So it's amazing. And you would think that with all this information, she would be doing it on her own, but she specializes in helping other people. But in addition, she has another hat of being a clinical researcher. She ran the stem cell division at University of Miami, and then she's been involved in more than 16 clinical trials, helping to run them. And she also trains and helps nursing students and other people in trials. So she does a lot of different things at a high executive function. So Darcy, thank you for joining us, and tell us about how you got started in stem cells.
Well, thank you for inviting me. I'm so pleased to be a part of your wonderful podcast. So I first got my start in stem cells back in 2005. I started at the University of Miami. I was there since 1997, and then I went into cardiology. But prior to that, I was in urology, I was in genetics, and then I went into cardiology. Why? Because cardiology was the one area of disease that there was hope in my mind, because you could always get a heart transplant. So with that philosophy, we also started at that time stem cells, and we were giving stem cells via IV to patients that had had myocardial infarctions within the first 24 hours. It was a funded study and several sites throughout the US. And that's how I basically got my passion for it. My first question when I started working there was, I will only work with adult stem cells. I'm not going on the embryonic. And they're like, no, we only do adult. So I was like, okay, we're good to go. This is agreed. And from there, in building out the Interdisciplinary Stem Cell Institute, I was the director of the institute. I ran all the clinical trials. We would get all of the FDA investigational new drugs application. We went from the heart. We started looking into Crohn's disease with fistulas, and then it took us to orthopedics, it took us to psychiatry. We started delving into spine issues. So once we started in the Stem Cell Institute, everybody was, tapping into this. And we said, okay, we need to include all disease groups. So from stroke, and then finally we just said, let's do one for aging frailty. And that was, I would say, our home run. From there, there was a spin out company from the university that started. I actually started the whole entire medical tourism program for them in the Bahamas. And with that, that just set the stage for where physician scientists can actually start in an academic setting and spin out their own biotech companies and become IPO, et cetera, et cetera. So it just opened up the whole new possibility worldwide for a bunch of really
Amazing.
hardcore scientific
No,
academics.
it's amazing, and that's the thing I grokked immediately. It's like you don't have an MD and you're an RN,
Yeah.
but the actual level of practical experience from the deep granular level of what words to use in your manuals up into the strategic FDA planning and approval and site inspection. You have put in the work to get that information, and you've helped along the way a lot of people in this space that have successful businesses. Some don't, but you're the gal they go to when they need to actually build a lab and grow out, right? Because there's a lot of people in this space who are making money. One of them we know and met, well, most of them actually, who white label. So tell people what that is, because a lot of people who are selling you exosomes, they don't have control, and it's all about control, isn't it, over their manufacturing process.
Right. I mean, so a lot of companies will choose to just do the lab, the white labeling from a lab. So that also takes a lot of investigation. So you have to, kind of pick and choose which labs and look at their quality programs and see if they actually have any FDA INDs, see what kind of regulations, what kind of HCTPs, or if it's a 361 or a 351, and just see what kind of compliance program they have. And you vendorize them, and then you finally say, okay, we'll make a deal, we'll white label this product and take it to another level. That's one way. And it's just making sure, one of the most important things that I always caution everyone is the label. Label is extremely important to make sure
Isn't it? Yeah. I used to make a supplement too. And we had that very tension-filled dinner with our colleague who got an FDA letter. And
Yes.
so, at the end of the day, on the one hand, it's kind of a fig leaf. Well, I don't know how they make it. But then again, if it's your product, shouldn't you know how you make it? So there's no one path where you're risk-free, is there?
No, actually, there isn't. And that goes with anything. I mean, as a physician, you would know you're not risk-free in even being a physician with a patient.
No,
They have to sign consents. There's always risk in everything. It's just how we mitigate them.
that's right.
One thing that's also important to note, I'm going to just put this out there for whatever nurses are listening, if they're listening. I am a nurse, so as a nurse, the possibilities and the realm is just wide open to really do anything that you want to do within your nursing scope, outside of your nursing scope. Don't
Yeah.
think that being a nurse, you're bedside. You're not.
No.
I went from bedside to making product to building GMPs to, going and training physicians and nursing staff on cellular therapy. So that
Yeah,
was
it says here you're the leadership succession chair for the Beta Tau chapter of Sigma Delta Theta Tau International Honors Nursing. But
yes.
again, let's have some fun with that because, training in OBGYN in the delivering of baby specialties, labor and delivery nurses are a special breed. They're like ICU nurses. They like taking charge and they have a lot of autonomy, a lot of great judgment. And so there is always that tension with the doctor who is ultimately going to have his name on the chart and the nurse, right? But
Right.
I remember they used to really ride us freshman year. Like they would make a point of like the first year as an intern, they would call you Mr. Park, and they just give you a hard time because they knew eventually he was coming back. But even talk about the gender differences because I know a lot of female physicians coming up and would have problems with the female nurses sometimes. So I know that they have different roles and doctors excel in sort of the rare disease critical management, but they don't know everything. I mean, it was very humbling last week to be diagnostician by an AI. This guy said he had multiple myeloma, and only the third year ER guy figured it out. Everyone else was on their own, confirmation bias, blinders, siloed thinking. So doctors can make huge mistakes, and I think for the lay consumer, why is it so dangerous to be admitted to the hospital? Well, first of all, you got the intake physician or team, and they might not get a good history. Like I had a patient in Miami, or it was somewhere around there, and I think someone forgot to write that he was diabetic. So the family member called me and said, I'm going to sue the nurse and the hospital because his glucose is 400. I'm like, well, that's probably why he's delirious. He's in ketoacidosis. But it's like not only are there failures in the system that can kill you from just not knowing what meds you're on or what disease you have, but you know it. These Sentinel reports rarely get filed. And someone screws up and they put like 500 instead of 50 of something like potassium. I mean, thankfully the pharmacists save both our butts. But you've seen it all the time, right? Like there are a lot of points of failure within the system. I mean, talk about that. Like, first of all, do you think that female nurses are harder? Because there's male nurses too. Are they
Right.
harder on the female nurses, or it's just interpersonal stuff? And then how can people avoid these medical mistakes when they're hospitalized?
Well, I mean, I would take it from everywhere in the field, right? Even in the scientific field, females have it very difficult. You're still
Yeah.
believe it or not, we're still in a man's world. You know, the pay scales are very different.
Yep.
Science, discovering your own science. I mean, how many women have to actually go into legal battles for IP and trademarks with the physicians or academics that they worked with? There's always that, there's some level of difference within the gender gap, right? So
Fair enough. Yeah.
I think we're not there yet. I think we're getting there. You know, when I could say doing clinicals and residents, hey, I would tell all the residents, I don't make you coffee and I don't pick up your gloves, so you better keep everything nice and clean.
Oh
And
no, we would never even dream. Oh my God. Yeah.
it's like teaching, raising kids. How are you going to raise your kids to be rambunctious or to
Right.
follow orders? And,
Right.
the nurses, I would say, are the heart of every single hospital and
sure.
every single training program, because every resident that you talk to, once they're physicians, will always sit back and say, there was this one nurse that was always so hard on me. And that's the one nurse, like that English teacher growing up in school, that you'll always remember.
Right.
And,
No,
and
they gotta keep it real. Yeah, no, and our nursing was revered where I trained at Beth Israel in Boston. So we knew who, was in charge. But I think it's interesting, but in terms of like I was shocked when you were on the stage in Mexico in Cancun. You were like, oh, the nurse gave my loved one non-warm saline, even though it was all over the chart that they had cryo issue, right? And so people make mistakes, and nurses are people. Therefore, nurses make mistakes. So,
right.
but I think sometimes people are a little hesitant to be advocates. But I really think that if you were to plot out the adverse outcomes with the time spent by family members, someone close by, there's times when the curves cross. Like you can be too much of a nosy Nelly,
Right.
but being there and showing that you care is important, don't you think? You get better empathetic care and receptiveness.
Right. And nurses, I will always say we are empathy, we are nurturing. It's the
Yeah,
heart of us, whether you're a male or a female nurse. I can't tell you that I see a difference. I see us all
yeah,
as one. I see
yeah.
the nursing profession as a true profession. And it's because of the way that we take care of our patients, our vigilance, and, just we're able to actually come down and put things in layman's terms to help our patients better understand. And they actually feel more at ease, and they'll tell you different types of medicines they're on more so than the physician, because I guess with the physician, they're just trying to,
Oh yeah,
not
they might have 2.5 minutes around, and that's it. Like you
exactly.
are the point of contact, exactly.
Right, right.
But it's so exciting for those that are watching to see that there's many different ways that you can pivot within nursing. So you chose to be mainly in clinical, but also in actually helping people build labs. And from that, I want to talk a little bit about your experience because I don't know a lot about stem cells. So I
Okay.
thought it'd be great if we asked the audience, or the audience can get the information from you. So in your presentation, you talked about, okay, we're only about 20 something years into the stem cell revolution. Here's the beautiful chart where they discovered the liver stem cell or the neuro stem cell or this. Now, the question I put to you is, you can, with induced pluripotency, we can get regular cells to become stem-like, right? And
Right.
it's always been thought that in an organ, like say the liver or whatever, a region of the brain, there's neural stem cells or there's hepatic stem cells. So it's like a queen bee. There's one queen per hive. Now the analogy fails there because there's many little sub niches within a liver. Some might be older or from a different queen, right? They live together.
Right.
But my greater question is, like, how much do we really know about stem cells? Because, every stem cell scientist will say, oh, I'm such a genius. I can give the MSC this, that, or the other factor. It'll become bone or cartilage or whatever, right? Great. But if you can do that, don't you think nature can do that? And so the follow-up question is stemness just a characteristic? Like, can they get regular cells to act more stem-like? Or what do you think? Do you think there's only one queen bee per niche? Or what's the missing piece here?
I mean, So for me, stemness is, our cells, the ability to grow and turn into different types of cells, right? It may be a
Okay.
temporary, it may be a changing trait in some cases. Sometimes stemness, as temporary as it is, can turn on or off depending on the environment or the signals the cell receives. So, for example, certain conditions in the body might take on stem cell, decide to specialize into a particular type of cell, maybe a muscle or a skin cell, and it might stop acting like a stem cell.
That's what
So,
I'm saying, don't you think? I mean, that's my intuition. Because like
right.
how we had to have had muscle stellate stem cells, and just because you see them now doesn't mean they'll be that in 20 days. So I think that the body has this innate ability to become more primitive and regenerative and stem-like, and it's on a spectrum. That's my intuition. I don't know,
Right.
but
I mean, one of the key features of stem cells, of the stemness, is it can be transient. It can come and go depending on the situation. And
interesting.
this is why it's so important for, the stem cells to keep, in order for them to keep their stem state longer, so that they could be used in treatments or in future studies in research. So, scientists
Yeah.
really need to keep on studying the stem cells in their stem state.
That's interesting. Yeah, I'm going in June to Hong Kong just as a total beginner to the Hong Kong International Stem Cell Research thing.
Uh-huh.
And next month I'm going to the exosome thing. But I love just being the guy who knows the least in the room because I get the most insight because I'm a total blank slate. I don't know. So, you know, but let's talk about the bioreactor because in your presentation you show this bioreactor and I did talk to the equipment manufacturers. And so for those that don't know, if you just put stem cells in a flask, they'll just stick to the plastic and just hang out.
Right.
So there's not a lot of surface area in one pentagonal flask. So they've developed these things that are like making spaghetti, right? They're like fibers with all incredible surface area. It looks like a bag hanging there, but there's so much more surface area, like a honeycomb, to make the honey. So if I'm waking up to, in half a year and I'm building my own stem cell lab, I'm hiring Darcy and she's going to buy one of these off the shelf bioreactors, they call them, right? So
Right.
explain what the limits of the bioreactor are, because I presume it allows you to have more live cells in that culture, right?
Right. So let's take exosomes for example, right? I don't work for Terumo. I'm not getting paid for them, so this is not a kickback I'm receiving, but I
Yeah.
will talk about the Terumo quantum bioreactor. It does allow for high density cell culture and it can actually enhance exosome production when compared to traditional methods like the flask. So, but it does depend on several factors, the cell type and the density, the media and nutrient supply, harvesting efficiency, the fluid handling and waste removal. So for me, the quantum bioreactor, it can significantly increase the exosome yields when
So when
compared
you're
to.
talking about, okay, so a person flies to Panama or Morocco and they buy stem cells and they typically number them in tens of millions. And so you might be looking at 10 million for 6 grand or whatever USD. But this bioreactor can keep alive, what, up to 1 billion? Like 1,000 million cells? Or what's the limit?
Yes, well, so that's the little trick. So some scientists that are very familiar with the mesenchymal stem cells and the the Terumo quantum, they've been able to actually fine tune conditions to maximize their exosome output while maintaining the cellular health. So again,
But
they
we're
know
not talking trillions and we're not talking thousands. The highest you
we're
can get
talking in
is,
billions.
yeah,
We're
1 or 3 billion maybe. Okay. Now, something that, as a layperson, I mean, I've never done a Western blot, I've never used a pipette except to mix wine in a contest. So, the difference between a passage and a population doubling, and I saw your slide and I kind of understood, but explain to us, because they take whatever's there and they move it to something else, and a population doubling is like an estimation of a doubling of the cell population. So can you give us a simple way to understand the difference between passage like 5, 6 and doubling 5 and 6? Or are they similar, overlap?
So think of a passage as a transfer of cells to a new vessel, and think of population doubling is being a measure of how many times the cells have doubled,
But
right?
is there a correlation? Not necessarily, right?
No, because for example, when we're doing passages, right, they're counted as P1, P2, etc. When you're doing population doubling, you're using a logarithmic formula. So that's the tracking. It's different. And then what you're also thinking of is as you move into passaging with the impact of the cells, the more you passage, the more stress you cause on the cells, right? But then on the higher population doubling, it could lead to senescence. So
Okay, so let's take it back because I don't know what I don't know. So you're
Right.
using terms that you understand. Like, so for me, for example, in my primitive way of thinking, I, I'm doing two things. I'm going to take out a vial from my donor, and I'm going to make as many as I can without compromising the quality. And then I'm going to use them for, whatever, 2-3 months to lay my exosomes, right? So is there a different phase in which you give certain factors to clonally expand and double, double, double versus keeping them alive and productive as little chickens?
Well, so that's when you're talking about the exosomes, the yield may change with your passage number. And just as the exosome quality declines with the higher population doubling. So yes, depending on how many times you're going to be, let's say with the mesenchymal stem cells, you're going to culture expand them and you're going to be feeding them over time. That's why it's really important to always have lower passaging
Of
because
course.
of,
I mean, that makes sense to people intuitively who understand the
yeah.
Hayflick limit and epigenomic gene silencing, and stuff just happens. Contaminants get introduced. But let's say I pull out my vial of 10 million mesenchymal stem cells, right? And I passage it 1, 2, 3 times. Then I have 2, and then 4, and then 80 million stem cells, right? That's
Right.
probably too low a number for commercial scale exosome production, right? So
I
I may
mean,
have to go to passage like 5, 6, get 320 and then 640, and then have my bag full of quantum teruma or whatever stem cells, right? So
right.
in that passage from my working cell bank or my archive to my working and doubling it 6 times, is that stuff good still? Mostly good? Sometimes good? You don't know?
You know, you don't know until you start doing all of your testing, right? So
Yeah.
we know that as the cell divides more times, you're going to have epigenetic changes, right? The genes are going to turn on or turn off improperly, affecting the function. You know that your telomeres are going to shorten, making cells less able to divide, which is also going to contribute to the cell aging or the loss. That's why you always want to try to use lower passaging for the therapies, especially with MSCs, because we know that they produce healthier and better quality exosomes at the end of the day.
Yeah. No, it's great. I mean, so it's really unknown. It's an active, constant quality control thing. I mean, you can look at the omics, you can look at the karyotyping. I
Yeah.
guess you could look at the gene silencing profiles, but that remains true as it does for us as people. Our cells also, the more times they have to double and double and have that reproductive burden without the telomerase recovery, well, it's stressful. So the quality is going to decline. Okay, so what kind of things, talk to us about a little of the horror shows without naming names of what can go wrong when you're trying to grow stem cells in a kitchenette in a strip mall in South Florida.
Well, remember, over time, their DNA, their omics change and the structure, karyotyping. So this is, what will basically cause the aging of the cells and they accumulate damage. The genes may not work as well. Chromosomes can also become less, stable. And the slow decline is your key sign of what cellular senescence is.
Yeah.
And this is they lose their ability to grow and to function properly. So
Yeah.
it's just basically taking all of the biological function decline into account while you're doing, all of your expansions and your passages and everything. It is a true science.
Yeah. No, but it's like animal husbandry. It's like, cows have to be like lactational, chickens have to be, fertile or whatever.
Yeah.
And you wouldn't keep milk in the fridge for 3 months. So like stem cell, your production line. I remember someone was accusing someone of stealing their stem cells and going out on their own. But they didn't know that they get old because, you don't know what you don't know again. So, but let me ask you a question because your slide referenced exosome isolation and centrifugation. And when I went last year to the International Society of Extracellular Vesicles Conference, I know that the early literature is largely focused on cancer diagnostics and using ultracentrifugation. And so there was some talk like it causes aggregation, it changes the corona or the protein coding, which may or may not have functional implications. So I know some people prefer just to use more of a tangential flow filtration. What do you think? Do you think centrifugation is harmful in isolation of exosomes? I mean, I'm not talking about, some centrifugation for initial processing, but I'm talking about for isolation.
I mean, whether it's the gold standard, the TFF is gold standard, it is becoming more popular. It's often seen as a better choice for certain processes because it's gentler, let's say. However, whether it's the absolute gold standard depends on the specific situation and the type of sampling being worked with.
Right.
I mean, for me, I've seen depending on what you're working with again. So, with the exosomes and how you're stressing them and, there's so many factors to take into account that
It really is magic. I mean, it's
depends on
even
this.
more complicated than wine growing. So I think that in the early days, people used bovine calf serum, which I think has been deprecated. And then there are manufacturers of bespoke, sort of artificial but safer, ways to give nutrition. What's the optimal nutrition for stem cells, do you think?
So right now, what a lot of companies are doing in academic centers is platelet lysate. It also comes from human blood and specifically the platelets. It's packed with nutrients and growth factors, just like the fetal bovine serum. And it's considered a good alternative to fetal bovine serum. I mean, it's human based. You don't have to worry about, any type of xeno issues. The only catch is it's more expensive and it requires extra steps to prepare.
Yeah.
But it is actually seen as more ethical choice, and it's safer, but it does come with the extra cost.
We age because our telomeres shorten and our stem cells deplete, but what if we could support both? I've been taking TA65 for 17 years. It's the only supplement I trust to support better mood, better sleep, and exercise recovery. And at age 57, I don't have any gray hair and I don't need reading glasses. TA65 is available now. Go to rechargebiomedical.com/TA-65 and enter promo code RECHARGE10 to save 10% off.
Yeah, I mean, speaking of ethics, I got a letter from someone who had defected from a company. He said, "Hey, I haven't seen you in a while. Use my product. It's from a 7-week trophoblast." And, I was an OB/GYN, so I know what that is code for. It's from an abortion, which is, I don't really have the same ethical valence as some people. I've been on all sides of the abortion concerns. But talk to us about, I mean, younger is better, but to a point. Most people don't realize that a newborn placenta, which is where the vast majority of these products come from, or newborn amniotic fluid, they are adult. Explain how they could be adult if they're from a newborn baby.
Okay, so, one thing that is also, important to realize is we call it age 0 cells, right? Because they're perinatal tissue. And they're donors. These are from mothers that are C-sectioned only. You don't want to get from vaginal births. That was one of the issues that a company many years ago did, and they had. I mean, it did not go well for anyone. But you can even take these adult cells and and they're still considered early passage cells, and it brings me to even talk about pooling from different donors. Years ago, pooling different donors was always frowned upon by the FDA. And this is, to help create more batches of cellular products or exosomes. And basically what pooling is mixing of the cells or materials from the multiple donors into one group just to make your process more efficient. However, you must follow the FDA guidelines on this. And it's, everything always comes down to safety testing, traceability, always tracking the product to make sure that you're doing everything within a compliant manner when doing this, because you want to there's the risk of contamination, immune reactions. So by doing all of the necessary compliance rigor behind making your product, you're ensuring that you're going to have a safe final product.
Right. And indeed, the product that I'm currently using is, like you said, C-section, not paid for, screened for 40 different infectious diseases. But I think that, people don't realize that back in the George Bush era in the 90s, like the idea of using embryonic stem cells was very exciting. But there were problems, as I talked to Dr. Martin, Scott Martin, about. There were problems, and one of the glaring ones was the formation of teratomas. Like if you get a cell that's too omnipotent or pluripotent, you can get these multi-germline cell tumors. So when I tell people that a placental-derived one is an adult, it means it no longer has all that embryonic capacity, right? But now you sit there, you've been there, the mom, the farmer, the grower of stem cells for a long time at University of Miami. Did you happen upon any of the tricks that no one wants to talk about in terms of, it's published what, PO2, what oxygen, what CO2, what nutrients, but did you find that your cells, since they are kind of conscious living things, did better with certain light, certain music? Because when we were in Cancun, they were treating it with this magical red, green, yellow Korean light machine, the stem cells that they were harvesting. And you actually volunteered for a procedure, which was brave. So for those that don't know, Darcy had a bone marrow aspiration, and I saw them take her sample and put it in the Korean light machine. Is there some sound of music or, some kind of magical light frequency that will make your stem cells happier, or did you not mess with the dark arts?
So one thing that I'll always say, in most of my experience in the manufacturing, and it was always women. And why would I always say that? Because women, I'm sorry, men, we are the best bakers. And I don't know if we would sing to them, whatever we did way back when. It was a lab that was totally women. We had, God rest his soul, Dr. Ian McNeese. He's since passed away, but everyone under him was a woman. And it was amazing. They made the best cells ever. So, that's my one thing. So I will say, yes, certain types of lights, photomodulation with the cells, certain types of music because of the vibrations. I'm torn
because I'm going to ask Duncan. I'm interviewing the CEO of Chimera Labs, who I know you've consulted for in the past, and you know him from University of Miami. I'm going to see if I can trick him into telling me, does he play like Bach or does he play like death metal, like German, because I don't know if you want the cells to be angry and putting out a lot of high quality healing products, calming products. If you play them like Brahms' Lullaby, maybe they'll just phone it in and give mellow exosomes. What do you think?
Well, I don't know. I want to say I read somewhere the other day, I think it's Beethoven's Fifth Symphony eradicates cancer. One of those one of the symphonies does. But it's all types of music. So it's always with the vibration though. Nutrients. You make sure you're feeding yourselves the right way. Yes, oxygen and carbon dioxide, some will help them grow better, some will help, just you're basically trying to change the payload, the stuff stem cells produce by adjusting the factors. So can you change it? Yes, you can. But the specific effects can just vary based on what exactly you're trying to achieve. So that's, you'll see the light, you'll see the music, you'll see different nutrients, you'll see different oxygen and CO2 levels.
Okay, so, nobody knows, basically. So that's why I use the analogy, they're songs of healing, because even from moment to moment, it's not, the cells will produce, I try to explain to people, you can get an average of like the 100 most commonly transcribed mRNAs or proteins and see the quantification. It's not a random distribution. But from every exosome to exosome on the less than visible nanoscale, they're like snowflakes. They all have different contents in them because they're actively produced, right? So this leads me to my final question. Okay, so in the university or in Miami right now, I went to a conference in the fall, and it was kind of fringy, but it was good. And there was a gentleman who I know I won't call him out, but he provides xenografts, right? Sheep stem cells, because the laws in Switzerland are that you can't use human stem cells as they do in Panama or Costa Rica or wherever, but you can use sheep stem cells. And I used to have a buddy at my golf club who owned one of these German sheep clinics. So the question is, my understanding as a non-scientist is that when you have the major histocompatibility complex antigens, or the personal identifying antigens, that stem cells from another human don't generally survive that many days. But from a sheep, they must survive even less. So my question in a high level is, are these sheep or other donors surviving and engrafting? And if so, what are the implications immunologically?
So, from my standpoint, xenocells, the immune rejection is far higher. They're not usually a go-to choice. I know some patients of ours have always, way back when everybody went to Germany for the sheep. But doing animal studies, we did many porcine studies because we'd have to do our animal studies to use the data into our investigational new drugs. And we would do, we put human into animal. And we saw that the pigs were getting granulomas. And so we were like, well, the FDA was like, no, we want animal and animal, human, and then do the human in the animal. So we did a comparison study and we published it. And, at the end of the day, the only thing that I can say is, allogeneic cells, they have the best chance of survival and success, but there's still a risk of rejection. When you're doing bone marrow transplant, you have to find a matching donor. There's the risk of rejection. But what do we know that can kind of buffer this, right? There's drugs to suppress their immune system. We know graft versus host. We already know Mesoblast came out with MSCs, and guess what? That's to treat graft versus host. So it's ironic how now the biological products are also being used to treat immune rejection. So I am a full believer of human allogeneic stem cells, but I did want to touch on a very important topic you brought up when you talked about embryonic tissues, the ethical concerns with that. Years ago, when I first started in the clinical trials, we had to prove to the FDA that human adult mesenchymal stem cells from bone marrow did not cause teratomas, did not cause atopic tissue formation. And I mean, we did multiple serial MRIs. Everything we did, we ended up publishing on it because they kept thinking, oh, you're going to grow a tooth in a heart, you're going to grow something in a hair in the kidney. And we just did all these tests just to prove how safe they were. And, this is basically where we are today, right? We're still asking the same questions.
Yeah.
But
no, beautifully stated. And, I appreciate that answer. But as an OBGYN, yeah, I mean, I can only go by my experience. So, I had a lady almost die on me with amniotic fluid embolism. So I tend to think it's, for whatever reason, not as safe.
Right.
And then, I took out plenty of ovaries with teratomas. And, yeah, there were teeth and hair and sebum in them. So that's a problem. So I would definitely balk at something that was sourced from embryonic. But it's not that you're getting the cells. Even if it's an exosome excretion, it maybe is a totally different song they're playing, right?
100%.
So, but I so appreciate you taking the time to explain and help clear my ignorance, because I really don't know what I don't know. So luckily you put in the hours and you've got the wisdom. So that's great. And I know that you probably didn't take equity in all these companies that you helped to build. So tell us about your new venture in terms of helping my neck crepiness, the Oleo, what is it exactly?
So yes, I have a dear friend. She's a scientist in Israel, and we just opened up. We're starting the beginning process of opening up a company, and it's called Ole Biome USA, and we will be the sole distributors of her product throughout the United States. This is a lipid serum. She has over 40 patents. It is wonderful. It penetrates so deeply through the skin. You feel the difference. It just moisturizes your skin immediately.
So it's like not hyaluronic acid. It's not collagen.
No.
It's like got lipids to make you like beef tallow face type of thing. Like,
Yeah. It's got
nice.
their own little patented technology. And what I love the most about it is it doesn't leave you greasy. And most of these high-end oils, serums, whatever you want to call them, have odors to them. This has
Yeah,
no
yeah.
odor. So it's great.
Amazing. All right, we'll look for that. It's going to be called, what's the name of it?
Olay Biome.
Ole
Olay.
Biome. I love it. Well, you look amazing. I know I'm not going to tell your age. I don't know your age, but let's put it this way. You've been over 20 something
29
years in the
forever.
field. So, yeah. Yeah. Okay. Excellent. I appreciate it. And the name of your consultancy is what again?
It's biological consulting.
Okay.
So my biological consulting is my company. I've had it since 2015, and I
Nice.
consult on INDs with the FDA. I consult on building out GMPs,
Love it.
helping patients with physicians with informed consent, IRBs, you name it. But I
Everything.
truly appreciate you having me on your podcast, and it was
Yeah.
a blessing meeting you.
Oh, yeah.
Great energy, and this is exciting work you're doing, and helping the public gain a better understanding of such difficult and
Thank you.
confusing times in the cell
Yeah.
therapy world.
I mean, everyone has, like I was telling Scott Martin, it's like it's hard to get a man to understand something or a woman if their salary depends on them not understanding it.
Right.
So we all have our biases. We're all trying to reach a greater truth. And so it was fun to be in rooms where opinions were expressed I don't agree with. But that's why more about the light than the heat. Because, whatever works, we're all hopefully on the same team. And so we're trying to figure out what works and what doesn't. So thank you.
Well, thank you for having me again, and have a wonderful evening.
Thanks for tuning into the Recharge Biomedical Podcast. If today's episode got you thinking, you'll love my book, Exosomes Songs of Healing. It's packed with cool analogies, full color illustrations, and all the science you'll need to understand how exosomes are changing the game in aging and regenerative medicine. You can grab it in paperback, ebook, or audiobook, whatever works for you. Now head over to www.rechargebiomedical.com to check it out. And don't forget to like and subscribe so you never miss another episode. See you next time.